live. All right. Good afternoon and good evening, everyone. Wherever you are watching, this is Tech Talk, brought to you by Tek Tribe. Tech Talk is where we bring on professionals, IT professionals who are making it in their respective field to teach us and also talk about their journey, right? My name is Olamide Kosile, and I'll be your host today. I also have with me Olayinka who will be supporting as the co-host, and we have our guest Tolani Akintayo, who is a cloud DevOps and platform engineer. Now, Tolani Akintayo is a cloud DevOps engineer and educator, known for building scalable production grade cloud systems and driving operational excellence across engineering teams. He has over 3 years of hands-on experience, and he has led initiatives around infrastructure automation, CI/CD transformation, cloud native adoption using tools like Terraform, Kubernetes, and GitOps. Tolani has also worked in different spheres of IT and cloud. He's also a mentor. His work focuses on reducing system complexity, improving reliability, and align infrastructure with business critical outcomes, helping teams ship faster without compromising stability. As I said, mentioned earlier, and beyond engineering, Tolani plays an active role in shaping the next generation of DevOps talent through mentorship, technical writing, and public speaking. He's also the product lead at Troflos, where he leads the development of solutions aimed to improving decision making and everyday outcomes for students. It's a pleasure to have you here, Tolani. It's nice having you here, and I'm so sure we
Yeah.
are going to have an interesting time. Faram, do you want to say one or two things before we go back to Tolani?
Words from you and
I think n- network there won't allow for me to speak. Right. Tolani, before we dive right into uh, common DevOps engineers' mistakes and how to avoid them, which we're going to be focusing on mainly today, I would like to ask you one or two questions. Tolani, a cloud engineer, a DevOps engineer, a platform engineer, how did you get into this? How did you get into cloud engineering and platform engineering?
All right. First of all, I have to say thank you very much for having me here and the whole introduction. It seems like a lot at some point, but yeah, going straight to the question, right? I think my journey actually started on campus, right? Very funny. We kind of had a IT class called New Horizon, as I studied here in Nigeria, Ogun State. And we went for that class. They taught us basis of web development, HTML, CSS, JavaScript, those bases. And then after that, I and my friend just thought of, let's take this to the next level, right? Let's do some cool things and all of that. And then we started going online to check resources like YouTube and many others, just to build amazing websites. Sometimes even Napa. And we kept on doing that. Then it came to a point whereby for me, I just felt like there was something more than web development for me, right? I didn't know what it was at the point. But then fast forward, I came across, I would say, my senior at that time, and I just called him to greet him and just uh, basically greet him. Then he told me a few things. He had been working, right? He had been working, I think, as a software engineer and all of that. Then at the end of the discussion, he made mention of DevOps, and I just took the initiative to search about it. I found the meaning and it just resonated with me at the point. And I was like, this is what I'm going to do, I'm going to learn. So I think that was like the starting point for me. Then after that, the question was like, I know what to learn. Now, where are the resources to use to learn? So I had to begin to search for resources. And at that time, at the part of the country here in Nigeria, there was not so much of resources, to use to learn and all of that. So I had to begin to search and search and search and search. And luckily for me, I found a resource grounded in it while on campus with the whole, activities for students and all of that. There was a time I dedicated about 30 minutes every day to just learn something new. Doesn't have to be complex, doesn't have to be very serious, just something new. And I remember sometimes not going for breaks because we used to have breaks, vacations. Stayed back on campus, just studying hours and hours and hours and all of that. But those periods were actually helping me to get the fundamentals right in cloud and DevOps, and it was very helpful for me. Then fast forward from that, did IT, and I think the journey progressed from there. To be honest, so I would say that has been my journey. I started from web development into cloud engineering. Yeah, I don't know if
Oh,
that answers the question.
yeah. It answers it did answered it. The next question I would like to ask you, how has it been? Does it really pay? Extraordinary pay. How has it been for you?
Hmm.
The journey. Now we know how you got there, but what are the sacrifices you had to make? I mean, what are discipline you had to inculcate and all? How has it been? Mm.
All right, I think that's a very important one. So, um, like I was mentioning earlier, there was a lot of sacrifice. Even a few weeks ago, I had the opportunity of going back to my campus to speak on cloud and DevOps, right? And I was still sharing a few of these things. So one of the few things I was sharing that I did the discipline, right? Because cloud and DevOps, you need to learn like a whole bunch of things, right? So at some point, I had to dedicate about 30 minutes every day to learn something new. I don't need about 3 hours, 4 hours because I was a student at that point, and there were other engagement, I had other leadership responsibility. So I just made a commitment of like 30 minutes every day. I'm going to learn something new. I'm going to add to my knowledge, right? And I took that commitment over and over and over. And there were times whereby, the school would go on vacation, but there were times where I stayed back and I would just lock myself in the room and just hours, hours, I mean hours. It was very boring because I would be the only one in the room. But those times were actually very important to invest for the time ahead. And honestly, like every other tech field, especially the cloud DevOps, is always evolving, always moving. Now we have the whole noise on AI and all of those things. So there is a mentality of adopt, which every engineer obviously that wants to go into adopt is learning and learning, continue learning. But even as much as that, is making sure that the basis, the fundamentals um, are very, you are good at them, you know them, you stick to them. Every other thing is an add-on. So I would say those are the disciplines I have to put in place. Learning and learning and learning. Yeah.
All right. Thank you. Learning and learning and learning and learning. Now, let's go right into the business of the day. We want to look at the common DevOps engineers' mistake and how to avoid them. So, in your experience, you're going to be sharing one of the things DevOps engineers do that they should avoid in their everyday practice. I have a few questions that follows that will follow this presentation. I've not even allowed you to present first, but I have a question
That's
pending.
fine.
Just to know something else pouring from my own experience. But before I go into that, um, Olayinka, do you have anything to ask Tolani before we go into the presentation properly?
Actually, yes. I would like to ask Tolani He actually said something very striking to me, which was dedicating 30 minutes daily to learn something new. So I would love to ask, especially with the evolving of AI, learning 30 minutes daily, or someone building a project, someone who is just new to DevOps, how can he use AI with this learning daily to actually develop himself?
Okay, I think that's an interesting question. I think I've gotten that question a couple of times. And what I usually say, right, and which is what I would still say now, is that to be honest, I think I would say that AI, yes, is it's in the market and everybody's using it, integrating it, but like if you look at it, there is a lot of noise. And when there's a lot of noise like that, you have to focus on the signal because there's a difference between noise and signal. You have to focus on what exactly is this whole thing, pointing directly to. So if you're going to use AI, like someone was asking me sometimes ago, he started learning DevOps like a month ago, and he was telling me, AI and all of those things. And my my own perspective is that one people would say don't use AI at all and all of those things, but I would say you should use it because if you don't use AI, then but you need the AI to actually work at a job, right? So my own perspective to it is that even as much as I'm using AI, use it as a learning aid to aid your learning, not to you know make your what your thinking or the work easier in a way. You still have to think through systems. You still have to be able to look at a particular use case scenario, think through it. What are the two services that can be used or will be best suited for the use case? But the AI can help you to break down things that probably you did not understand properly while you were probably going through a course. It can give you different scenarios, different use cases of how engineers have used this certain tool or technology. It can widen your mind to see what the possibility that exists, but not trying to use it to answer questions or solve things. You can use it, but at the stage of you trying to learn as a beginner, it is important that you make sure that you understand the fundamentals, the basic things like Linux, networking, all those things, because those things don't change, right? AI that were shouting about still operate on infrastructure. Nothing has changed in infrastructure. So that would be my advice on that. I don't know if that helps.
Yeah,
Thank you
thank
very
you.
much, Mr. Tolani.
Yeah, so
Thank you.
don't just use AI. Don't just use AI. Understand what AI is doing for you. So what Oladi is saying in at large is don't outsource critical thinking to AI. AI should be a
Yeah.
tool. AI should not be your mind. All right. Thank you so much, Tolani. Let's go into the main subject for today: common DevOps engineer mistakes and how to avoid them. So I will just hand over the mic to you and let you do your magic.
All right. Thank you very much. Okay, let me try to share my screen. Let's see. Okay. So what I'm actually going to do, right, is definitely I would share experiences, but that is actually the fact that I looked into the community, and I know that it's a community of training, mentoring and helping engineers to grow professionally, and I had to tailor what I'll be speaking on because I know there will be a lot of people that are currently learning, right? They've not probably Definitely there are people that will listen to that have been working, but I just really see that a lot of people that will be probably in the community, some the people that will be learning, they are still in their learning process. So that perspective made me to want to tailor it and make it as basic as possible, right? Yeah. All right. So I think the first thing I would love to really talk about is that making mistakes are in a larger percent in a very large percentage is not totally avoidable, right? We will make mistakes, and a good environment, or I would call it a good system or working environment, and it should be built in such a way that when people try to make a mistake, it does not actually, I'll use the word, affect your structure. Just saying that people should not make a particular mistake, it's not going to actually really work, right? I don't think it has really worked. But putting in systems that if one person, for instance, let's say, open a server to anywhere, that particular server is terminated because you put in compliance, right? That in itself is going to help because the system has been built around that. So I think that's the most important thing I really want to say. So not making mistakes in cloud DevOps engineering is beyond just you trying to be disciplined as a person, is putting in the discipline into the system that you are operating, right? Very important. So like cost, right? When you put in when you put in services like Cost Explorer, and those services, you analyze the cost that you should be notified of. It reminds you because you can easily forget. So the mistake, avoiding mistake is most important for actually for it to be built into systems rather than actually you as a person. Obviously, as a person, you have to be disciplined. You have to know. You have to know the things you ought to do, the mistakes you have to avoid. But definitely, if you put in those uh, structure into the system, it becomes more effective and resilient. So we'll go into it. And the idea of all these mistakes, everything are very, very, very basic. Most of it are very basic. Is not for you to not make mistakes, but if you perhaps make a mistake, right? The goal is to learn from it and build structures that makes it impossible to make mistakes again, right? That's actually that's the end goal of everything that we're talking about today. So let's get right into it. So, like I said, I tailor this to people learning and also people building also. So in one way or the other, if you could have experienced, let's say, an incident that had to have everybody, wake everybody up, or you had heard of it. If you have not had the experience, you must have heard of it. You have a lot of news, happening, AWS outage, Azure outage. There are a lot of them, right? If you are really, really active in what is going on in the tech market, you will have heard of news of these things. How that there was outages, production was broken, security breach, tons of them, right? You would have noticed them, right? And the goal, the most important thing, if you notice, right? Because I have taken time to look at a lot of these mistakes that we experience, right, while working. And if you look at most of them actually start, or they emanate from, let's say, some little foundations of little mistakes that piled up over time and then became something that called for everybody's attention, right? So it's still very important to actually look back to the basic, the fundamental things, right? And see where the loopholes can be, where the mistakes can come into place and fix those things, right? And that's what we're going to be learning. So we're going to be teaching. So, and more of the reason why we have like a post-mortem, right, of incident reports. When there's an incident, when there's anything that happens, you make um, a note on it. What happened? What caused it? How do we prevent it to happen? And if that is done correctly over time, it becomes an institutional knowledge for that organization, right? That you can look at and learn from and avoid any mistake of that to happen again. All right. So the first one here is I'll be starting with infrastructure because the mistake that I'll be talking about, spans across different layers, and I would like to start with infrastructure because that's actually the first thing because your application runs on top of the infrastructure. So the infrastructure is the basis of everything, right? And because I'm also privileged to also teach and mentor people in their journey, right? Teaching them all these basics of cloud and DevOps. I also see a lot of mistakes from that level, right? As much as I've seen mistakes too for people working, let's say in startups, Even myself, right? Mistakes I've made. I believe every engineer would have made one mistake or the other, right? It's just the way it is, right? So one of the mistakes, right, is using the root account. And it sounds very familiar because it is, but I believe it's worth actually talking about. Talking about, especially for people that are just learning, people that are just in the journey, right? To see these things and avoid these mistakes very quickly. Using root, you don't want to use root because, for instance, if you open an AWS account, right, you automatically have the root user. The ideal thing is for you to create a new user, a new IAM user, an admin user to use for specific things, right? You could create a user for specific things, right, for day-to-day activities, right? And the idea of that, right, or the reason for that is that if you use the root user, right, and it gets compromised by any means, the person that basically has access to that root can do anything because it's a root user. Yeah, it's a super user privilege. It's an admin privilege. You can do anything. You can basically even create a new IAM user. Do a bunch of. He basically has total access to the accounts, the organization, basically. So that is the reason why it is important to not use a root user. You can use the root account or the root user, right? When you want to do specific things, like specific things that requires admin privilege. Let's say you want to uh, lower the privilege of, let's say, other users, let's say a developer, just to read and not to write, different things of that nature, specific things. But for day-to-day activities, the root account is a no-go area, right? And it's very important. So for that also, that's a fix. But now to be able to prevent that from happening, because we've had cases whereby you have a junior engineer come into the company and then mess up things, right? Because they're just doing their thing and they just mess up things. And most of the times, we think is actually like the fault of the junior engineer. It is, but to a larger extent, the system was not built to be able to handle such things, right? Just imagine if you are trying to use a root account and you built a system around it, right? Like an helps SCP to block root usage, that will not be able to happen. You'll be able to know that somebody was trying to do something and be able to rectify that action immediately, rather than it causing a lot of issues. The second thing here is building from the console. A lot of beginners build from the console, and ideally, that's actually the first place to start from, right? It's just the first place to start from because whatever you're going to be doing in Terraform, cloud formation, or any infrastructure as code to, right, is something that's already on the console, right? So you're not doing anything new. They're just basically taking everything from the UI to code. That is understandable. But when you're coming into production environment, you cannot use that. It's not You shouldn't use that. Why? Because your whatever you do cannot be easily reproducible. It's not even reproducible. It cannot be referenced. If you perhaps created a server, deploy certain things, someone else cannot come and do the same exact way you did it. So the idea, even for beginners, right, is to begin to learn this infrastructure as code too, right? To do the same thing that you are doing on the console, do it in Terraform, do it as code, because it can be versioned, it can be shared, you can repeat the same thing, exact the same thing every single time, right? So that is the idea of that. That is the why that is why it's important because if you beat anything through the console and then you're using Terraform to do some other things, Terraform is not aware of that except you import it, right? So, but the benchmark for production uh, applications, production services is infrastructure as code, right? So we are still on infrastructure mistakes. The third thing is having an account for everything, and for me, I've seen this in startups because I've been privileged to work for multiple startups and also actually working in one at the moment. So I see that because you are trying to, and in that case, you just have let's say like one DevOps engineer, or yeah, in most cases actually. and then you just have an account. The goal is trying to ship things, to the market so that users can see the new features and all of those things. And then you forget some certain disciplines that need to be put in place. Just having one account for everything, that in itself can cause a lot of issues, right? Because let's say if the developer is trying to create a server or do certain things, right, or something specific, something, let's say, just trying to create a database or use Terraform to do something simple, it can interrupt, or it can basically affect production savers. So the ideal thing to do, even for a startup environment, right, is to have an organization, and it doesn't cost anything. At least in AWS, as far as I know, it doesn't cost anything to have an organization. You can create a dev account, a stage account, as many as you need, but obviously dev, stage, and prod, and then you can do all your testing, all your checking how the application will behave in dev account. So the production account is isolated completely, and nothing can affect it. Nothing from the dev can obviously affect it, be it the database, be it the servers, whatever it is, right? So that isolation is very important. Putting a separation of concern is very important. And that's like a very basic thing that actually shows that you it is basic thing that actually shows that you actually understand security at the lowest barest minimum, having organizations, right? Okay. So the fourth one, looking at this, right, it just seems, oh, this is not even possible. Who would do this? And you know, to be honest, I don't think anybody should do this. You don't put your database in the public subnet. You do not. If you don't want to. You shouldn't be. Nobody does, because your database actually contains, sensitive information from the users, and then shouldn't be in the public subnet. Should not be accessible publicly, basically. But I see so these mistakes from beginners, right, trying to learn, and obviously these are things that um, I correct. And I think even the most important thing for a beginner is actually what I do, what I use, right, in teaching is actually to have a reference architecture, because these are actually organizations, enterprise actually work. You don't just say you want to deploy something and you go ahead and deploy it. It doesn't work that way. You need to have a reference architecture. No matter how basic it is, no matter how simple it is, there's something that you need to reference. Obviously, in bigger organizations, you have solution architect that does the whole design of architectures for what needs to be deployed. But even though as a DevOps engineer, you definitely have a knowledge of a lot of things. So having an infrastructure, having an architecture design down shouldn't be a problem of what you need to deploy, right? It's actually even the most basic thing you need to do, right? Even before you implement anything, before you go ahead to, let's say, you want to deploy something, you want to write a piece of configuration file, have an idea, a mental picture of what you want to do, just something small, a pictorial representation, something diagrammatic of what you want to do, and then that guides you on how to do it. So if you are doing that, actually, in the process of actually doing that, all of these things can actually be avoided, because you will see that you definitely your database are going to be in private subnet, even your app savers are going to be in private subnet. It's just your nav gateway, load balancers, and a few other services that's going to be in the public subnets, right? So I actually recommend having a design and architecture of what you want to implement, right? And I think if you obviously have the in quotes the credit, or let's say to run infrastructures, always run them production grade, because that gives you a standard of doing things like that every single time. So even if you want to basically deploy a simple web server, have your PPCs, your public private subnet, NAT gateways, all these things in place. Do it production grade, right? Because if you maintain that standard, it would be part of you. So when you are doing anything production, like, you will not make that mistake, right? And a beautiful way of actually accessing applications, right, privately, is using the SSM session manager. It's very awesome. You don't need any SSH. You don't need to open port 22. Just access privately and securely, right? That has actually been very helpful for me. Okay, so that's on infrastructure, and I think we are going into, I think, security. Yeah, security. So this is a very, very important one. Security, very important. So some Very funny, but companies have actually ended because of we're not securely, administered. Actually, there have been breaches, data was exposed, collected, a bunch of things, and that is why this session is very important. So the first thing here is uploaded credentials. In as much as it seems like this has been said a lot of times, we still experience it, we still see companies falling into this, right? And that's why I think it's very important to go back to the very basic things and reiterate on it, right? So upgrade credentials, for instance. So you shouldn't upload your credentials, right? That is why you have tools like services like Secret Manager on AWS to have your sensitive information in it. If you have anything like non-sensitive information, you have a parameter store, put them there, and even the idea of credentials is the best way is actually to be stored separately, such that your application can actually be able to retrieve them at runtime and use them so that and dispose them. Nothing is stored in Git, nothing is stored in the pipeline, all of that. All right. Very important, very, very important. And the fun fact is actually that, for instance, in Git, right, in GitHub, attackers actually scan GitHub repos like I think 24/7 with their bots to see if there's any credentials or any insensitive information that is exposed. So if you by any mistake, push any EMV file, whatever credentials into the GitHub, you just have to assume that it has been compromised. You deactivate, you rotate it immediately because of how attackers in this current time and age have become very sophisticated, right? And a few ways to actually fix that is you can use your Git secret hooks. So what this does, what this does is that uh, when you're trying to push changes that have secret credentials in it, it stops it, right? And then, like I said, you can use the secret manager to store it, and you can retrieve them at runtime, and they are being used. So another important one is the CI/CD. So I think I talked about this 2 weeks ago or thereabouts. The OIDC, very important. OpenID, OpenID authentication, very, very awesome, right? So if you're trying to, let's say, authenticate between, let's say, GitHub and AWS, for instance, it could be Azure, it could be anyone, right? Instead of using your secret access key and access keys like you would normally do, you store them in your, GitHub secret and all of those things, and you reference them in your GitHub workflow, CI/CD pipeline, and all of that. You don't need any of those things. So just implement the OpenID authentication, and none of the two parties sees any credentials, right? All that is being passed to JWT token, a JSON web token that is being passed and validated, and that's it, right? And the beauty part is also you have these GitHub runners that are just after running the job, they are being destroyed. So that in itself increase security at that level of CI/CD pipeline. All right, okay, another one. I actually have a bunch of them. I'm even thinking we will not probably finish them, but I think we should actually. So let's see how far we are able to go. So administrator access on everything, right? Yeah, a lot of these seems familiar, but I still took the initiative to go through them, right? So if it seems familiar to you, I still really feel like you should still look at them, right, and make sure that you are not falling short of any of these things. So like even personally for me, in the startup I'm currently leading, right? Just have few engineers, nothing really much, just a startup pre-launch stage, and then you just said, okay, just give them admin access to just do what they need to do, nothing much, right? It seems very simple, it seems very basic, but the truth is, immediately you make that kind of decision, you most likely will ignore it and just go on doing other things and think everything is fine until the point whereby there is a compromise, right? Nobody actually plans for the assistant to be compromised, right? It's something that has been built up over time, right, by neglecting certain basic things, right? And then all of a sudden there's a breach. All of a sudden there's an attack, and everybody's panicking and trying to recover from it. So in that case, for me, right, in our startup, what I had to do, right, was create a basically a user for the developer and limit the permissions, because that's the whole idea. That's the whole idea of least privilege. You only give the permission that are needed to do certain things. So for a user like a developer, he just needs write access, or you need to read access. I mean, you can create the users for him as a DevOps engineer, and it does what he wants to do. The permissions. The same thing for, let's say, a role. Just create the permissions specific to what they need to do to get the job done. Nothing more, nothing less. Because adding admin access to a role because it just covers everything, or most times actually but let's say you want to deploy to ECS or EKS, using your GitHub action pipeline to AWS and all of that. There are quite a number of permissions that you have to be able to grant, the role that will be attached, right, to be attached to allow that to be done, like ECR repos, ECS, a lot of them. So sometimes it can be like it's a lot, right? Especially for smaller companies, but it's not a lot. It won't take you more than it will take you a few minutes to do that, rather than wait for when when there is an issue, a compromise, and you use hours and days to try to fix it, right? So the idea is just to do what is needed at the time it's needed. Give permissions to the role, service, or the individual based on what they are to do at that level. And that's just it, right? Secret rotation, very important. And I think this is something that the OpenID authentication actually solves when it comes to the CI/CD pipeline. Can also be used in different scenarios, right? And if you don't have an idea of what the OpenID authentication seems like, it's still the same thing you basically use when you go to a website and you need to, like, you sign in using Google. That same concept, that what happened behind the scene, is the same thing that OpenID does, right? It's basically the same thing. But in this case now, you are now, because in that case you are trying to verify your, let's say, you're trying to verify your identity to an application, right? But in the case of, let's say, GitHub Actions to AWS to deploy infrastructures on it, you are verifying a particular uh, GitHub workflow now to AWS. So it's not like an individual now, but it's still the same concept, right? So that in itself, you don't need any rotation, because for every job, every key that is being dispensed to be used for every job is destroyed immediately. The job is done. The runners are destroyed, right? And that's just it. Goes off. If anybody is able to even intercept and get the credentials before they are able to use it, it's not valid anymore, right? Very important, very very important. And even though obviously, let's say you don't have that in place, having secret rotation is very important, very very important, because you don't want to have a particular, let's say, even password, any sensitive information that is still being, that is the same for, let's say, over months, years, right? Because when that happens, an employee that probably leaves the organization and, let's say, has an issue with the organization, can use it, to mess up things. You don't want that. But even apart from that piece, it is the standard that you basically automate your secret rotation, and this can easily be done now with these services on cloud providers, right? You can easily rotate them. You can configure those settings. All right. So for okay, very important as well. So secret scanning in CI/CDs. Recently now, we had a lot of compromise on npm packages, modules, like a lot. Even Trivi had, some issues recently as well, whereby from a certain version of Trivi to a certain version, I can't remember the exact versions, was being compromised. So if you are using those versions, you have to basically upgrade. You have to basically increase to the versions that are not being impacted. So what am I saying in essence is that even in your CI/CD pipeline, whereby you automate different stages and steps, right? It is important to be able to have stages that actually scan your uh, your images, right? You scan it to see if there are any vulnerabilities in it. Very important. So it could be high critical vulnerabilities, so depending, right? And based on that, if it's low, it does not move to the next stage. If it is If it is okay, standard, it can move to the next. So you put in measures to make sure that nothing is hit into production that was not meant to be, right? Because I think the worst thing is actually to get to production and your applications are live to users and they are trying to, troubleshoot, find a way through it. The tension is not, it's not supposed to be, right. You are meant to be, it happens, yes, but it shouldn't be. It shouldn't be like that, right? The idea is to build a system such that these few things are put in place, and then you just everything just works the way they are meant to work, right? And if there's any issue at any point in time, you are notified of it. You address it very quickly, even before the users are aware of it, right? I think that's actually how engineering actually is meant to be. Okay. Hmm. All right. Pardon my slides. But yeah, so moving on to CI/CDs, right? Yeah, this is we talk about infrastructure now, mistakes in infrastructure. Talking about mistakes in security. We're talking about mistakes now in the CI/CD pipeline, right? Because uh, for a DevOps engineer, right, platform, you do a lot of work within your CI/CD pipeline to be able to automate all the steps, right, from building to running, to testing and all of those things to deployment. Very important. So in that particular case, it is very also critical that you don't your images are tagged version, they are version based on you know the semantics you are using, the numbers based on what you are doing, but it should be versioned, maybe version 1 point, however it is being done, right? Different teams have different ways of it, but you can have version 1.0 and all of those things, minor, major, and patches. So you should by no means actually use latest, because the issue with latest is such that if you use it right, if you are trying to, let's say for instance, roll back in a particular case, there is actually nothing to roll back to, because it is the latest version. It's still going to be the latest version. If you are trying to go back, there's no memory of rolling back, right? So there's an issue when it comes to rollback. Second thing is that you're not even able to track, you know, you're not able to track different versions of your applications because they were not actually tagged properly. So that's why having latest is important. And the standard way of doing it is to tag your images with the git char. So the git char is a bunch of cryptographic numbers that basically makes every commit, every changes to every application very unique, right? So you use that, and that makes it very unique. That makes every application, every new updates to your applications unique, and you can be able to trace applications based on that. You can be able to roll back to a specific version. Let's say, for instance, you push to production and there's an issue, you can roll back immediately, right? And that takes me to the rollback. So I was I was okay. I made a post on LinkedIn, but today, but the idea, right, and the way your CI/CD pipeline should be such that you even your if you are trying to push to production, even the user should not have been noticed, right? What is, let's say, the new update as an issue, right? Before you have realized it and have rolled back immediately to a stable version, right? And this boils down to your rolling strategy depending on what is being used, blue, green, canary, all of that, right? But my main focus is that you should be able to roll back if there are any issues, right? Just imagine you pushed a new version and then there's no system put in place to roll back. Just think of it. Then you go into minutes or even, let's say, hours of trying to debug and bring back the application into a stable state. What could have been done in less than, let's say, 5 minutes by rolling back to a stable version and trying to go ahead to identify where the issue was, and be able to solve what happened with the last deployment and move on from there. Users do not have any, it doesn't have any impact on users, and everything is moving smoothly, right? And actually the benefit of having a rollback strategy. If you don't have that, then you are actually not ready to push to production. That's just it. You're not ready to push to production, because if you are pushing to production, the question is, if there's an issue, because it's not about if there would be an issue, there can be an issue. So you have to build systems that are resilient enough that if there is an issue by any means, the impact should be as limited as possible on the users, right? And okay, and that is where runbooks comes in place, where you have steps to take when there are certain issues that occur, right? And that's the beauty of documenting. I think we'll get into that, but that's the beauty of documenting every single thing that you are doing, the steps you are taking, so that you can be able to reproduce the same thing over, right? And a very funny one is Friday deployment. Very funny one because and the issue with this is obviously Fridays. People, everybody's already thinking of weekends. The team's velocity, is already low, and deploying at that time, right? If there is an issue, may not be very good because the engineers would have probably gone, you know, or relaxed, put off their phones. They are basically ready for the weekend and all of that. So it's not ideal to actually deploy in production. If you are going to, then you have to put in time intervals and make sure that our engineers are available if there is any issue at any point. But ideally, it's not really advisable. So I think that's something to also look into. Very important when there are, let's say, holidays and all of those things, right? Very important. Okay, so no staging environment as well is an issue I've seen as well. I've seen not just in when it comes to cloud account, but even in Git itself, like Git having dev stage and branch, right? Because obviously you can have more than that, more than those, but this three is the bare minimum you should have. And there is a reason for those three stages, right? The dev is to test things, break things, developers have basically a lot of permissions to that environment. They can do a bunch of stuff, test the application, break things basically. And then the staging is where you basically simulate the staging to the production environment, right? Let's say by using um, information and data that are very closely to what you have in production, and then you basically build your application, you deploy it, you do everything in the same place to actually see what will be the impact when we are trying to deploy in production. That's the whole idea. It doesn't mean that there may not be issues in production, but you have been able to obviously catch a lot of issues that can occur in production. So omitting the staging environment and just going from dev to prod is actually very disastrous because you don't have any environment now to checkmate, right, certain issues that could happen. Let's say performance issues, right? User acceptance testing. These are things that are done in staging environment to check load testing, a lot of testing. This is where the QAs, product manager, they come in and test the application to make sure things is going to work as expected in production, right? So it's not optional. It's actually a path to actually move to gradually from dev to stage to production, right? And that's I think that's all for my CI/CD pipeline. Let's see how many times we've been able to use. Okay, so all right, okay. So we're going to cost. It's a very also important part. I had to break them into different sections, right? So we talked about infrastructure, security, CI/CD pipelines, you know, and then cost. Cost because this is also very crucial in every environment because you are coming as an engineer to obviously be able to save cost as much as possible and still be able to obviously use services that would be um, best fit for the use case, right? In that particular case. So you have to be able to think in trade-offs. Oh, should we deploy to ECS or EKS? Or which one will be best for our use case, right? Oh, and you are those obviously those decisions have to be based on different criteria. Like let's say what is the team currently? How much understanding do they have in Kubernetes? How much money does the company have to power this, right? You think in terms of also how many users are we going to be uh, handling and a lot of details. That will guide actually in making certain decisions. So there's no absolute, use case or solution to a particular problem. You have to look into the use case, look into what is on ground, understand it, not just the infrastructure, but the team, everything. And then based on that, that would guide on the best fit of the solution to use. So looking into blind spots and burning money, I've spoken about this fact that customers find issues before you are able to even locate them. That's a mistake. That should not be at all. right? You should build in system monitoring system such that when you deploy a new application, you can be able to within 5 to let's say 15, 20 minutes, you're able to check the monitoring dashboard, to see how the application is doing and you see how things are going perfectly, right? That should be in place. That's monitoring should be in place. Able to check so that you should in house be able to know when there's an issue before the users complain about it. It will be very, very disastrous to see a user of your application now beginning to tag, let's say, the company on Twitter, like we've seen many times, because there was an issue that they are facing and was not being solved, or probably the engineers in the team did not actually quickly notice, right? And that can be solved by putting in monitoring in place. You could use Prometheus and Grafana, CloudWatch, if you are AWS centric. But the goal is to actually be able to have insight to what is going on before the users actually face the issues. So, very important. And okay, awesome. Alert fatigue is a lot. And I think this is a lot. Yeah, this is a lot. Also, this is also an amazing mistake I've seen. Right, having alarms for everything, CPU, memory, like every single thing. Right, and it's. I think it's obvious when you begin to when you start and when you come into the field and you begin to learn. It's possible to make certain of these mistakes. Right, especially if you're in a startup and you don't have like a lead to guide you, right? You can make a lot of these mistakes. But the goal is actually to focus on alerts or focus on specific things that would directly impact the user. So when I mean specific things, I mean things like, let's say, latency. So how fast can users access the application, right? Are they trying to access your application to the browser and it's taking them forever? That's an issue that a user would not like. So that is one of the things you look into and map into how to monitor it. What are the metrics to use to monitor this? You look into things like error rates. Oh, your users are trying to make payments, they are getting decline. How many errors, how many issues have users gotten, let's say, in the space of, let's say, 24 hours? You track those things, and your goal is to reduce it to the barest minimum, right? So uh, these are few of the important alerts that you put in place, right? I was speaking to a friend, she's into SRE, and I was trying to really look into SRE at some point, like deeply into it, right? Because yeah, I obviously as a DevOps engineer, you do generally everything, but SRE they have specific focus to reliability. So we're discussing and looking at how you put alerts into place and you monitor things properly, because they have things like SLA, SLOs, which are very important, right? And that was months ago. One of the important things, right, is to be able to focus on alerts that are important, right? Because if you have alerts that you are being pinged, or let's say you are being notified on Slack or whatever platform you are using, right, of any issue, and you check the issue and see that, oh, this is not really a big issue actually. When you notice that, then that alert is not actually very important, right? Because if you continue going down that route, what will happen is that you will develop the habit of just ignoring what you call it, ignoring alerts. And definitely a time will come whereby alert that will be triggered would be very important, and there will be low reactions and users will be impacted. So that's why it's important to focus on putting alerts for specific things, right? And you can start by just looking at the problem that users are facing. Nobody builds a full system in just a day, right? It's a gradual process, right? Every big company that you know right now started somewhere. So wherever you are right now, you look at what problems our user faced in the last 1 week. You analyze it to see, oh, how can we reduce these things within in-house as an engineer? You look into those things, and then you look what are the metrics that we can put in place that will be triggered when this is actually about to happen. CPU utilization and all of that. When you think that way, you are thinking in a proactive way. You are not being reactive to, let's say, when issue happens, right? Very important. So, okay, one more we have here is cost control. Cost control, very important cost control. So, uh, I've had the experience, right? So I obviously usually have an account whereby I do demos and practice and learn and improve my skill and all of that. And I think I made a mistake actually. So I had like some credits, right? And I didn't track the credits. Was meant to last for 6 months, so I didn't track that it has expired. So I was already incurring cost and thinking that my credit is covering because I haven't used so much, right? In that particular scenario, and I found out that the credit has expired, and my cost that I'm incurring is actually I have to pay for them, right? And that could have been avoided in that case if you know okay, it was actually I actually put alerts in it. My case was actually specific. I was not tracking the mails, the particular inbox for that mail, right? I was not concentrating on it, right? Because I don't really use it that much. I use it once in a while. That was what happened in that case, right? But I could have prevented that, right? I could have probably included more of my email account I visit regularly, in that case. And now I don't have that issue anymore. But either ways, um, the cost was actually waived off, and that was that. But my idea of saying that is to be able to have budgeting in place, right? And when you're able to have budgeting in place and you're able to you're able to basically use a lot of services like Cost Explorer and many services that cloud providers, provide for us. You can be able to see into what service is actually using, you know, the most amount of, cost, and you can see what is the reason. Because one of the ones I've seen personally is Nav Gateway, right? Nav Gateway incurs a lot of cost, and most time people do not understand why a Nav Gateway should actually incur that amount of cost, right? They don't really understand the whole idea of how the NAT works, right? So because the NAT gateway is actually quite cheap, but when you are doing data transfer, right, through it, the cost begins to skyrocket, right? So if you don't have an idea of that, you would not really understand how to be able to save cost for your company. But if you know that data transfer, you are trying to move data from, let's say, S3 to EC2 or to your servers, we can do that through another means. We don't need to do that to the NAT. There are other means you can do that on AWS, for instance, right? You don't have to do that. You can do that through endpoint. You don't have to do that through NAT. So that saves cost for you, for the company. So it is important. Yeah, it's important because the whole idea of your skills, the knowledge, engineering is to be able to add value to the business, right? If whatever you are doing does not add value to the business, then it's as good as you're not doing anything, right? Things like saving cost, helping deployment to be smoother, faster, the system to be more reliable. These are things that impact the business directly. And these are the things you need to focus on and make your skill to be channeled towards. Right. All right. Okay. I think we're wrapping up. Okay. So some um very, very good stuff, but can cause issues. So automation, as you all know, you'd have heard a lot, right? Automation, DevOps, automation. You have to automate everything. But when trying to automate, for instance, right, you actually have to look at what exactly is taking the most time. You have to start from there. Yeah, because if you are automating something like, let's say, using creating a database and installing all of those things on it, and you have your CI/CD pipeline that is still taking so much time to do, to deploy a service. Let's say when you're trying to build and push a Docker image, for instance, right? It takes a lot of time because the way the Docker file, was written is or the base image that was used contains a lot of dependencies, so it takes a lot of time to actually build and push it. These are things that you need to look at because deployment directly affects developers' time. So if your deployment is slow or let's say not as fast as it should be, it affect the developers' time. So before they can see the changes being deployed to production and see what is being done, it takes that time. So the goal of automation, because when you hear of automation, you hear of anything you do more than twice to be automated. True, right? But it becomes more productive when you automate things that actually take time the more within the organization, within the project, right? What takes me a lot of time to do every single time? You tackle that first. By solving that, you saved a lot of times for the developers, a lot of time for the team, right? So, and that's something I wanted to focus on when it comes to automating, right? Don't just automate every single thing. Yes, you should, but the focus of automation is to make things more predictable, faster, less time consuming, right? And you should start from things that take the most time actually, right? And another is I've talked about run books as well, right? Run books, being able to have run books on specific things or specific things on how to get to take on specific things. Let's say that there is a specific issue, database is utilization is let's say 80%. What should you do, right? What should you do? And the idea of run books, right, is because in some organizations like one I've worked with, right, and I had a senior engineer was under him, you know, he knows the in and out of everything. When there's an issue, you need to call him every single time. That's not being productive. That's not the best practice, right? You should be able to have the knowledge of what you have being written down, being documented, such that somebody else or a new engineer or a junior engineer can pick it and be able to do the same thing that you would have done if you were in the team, right? And I think that's probably an issue also that many teams face. An engineer has all the knowledge, right? So if he leaves the team, everything goes down. It might take weeks to be able to get back on track on things as it should be, right? So run books are very important, right? Very, very important. And it's something that you keep updating based on the experiences that you have with your infrastructure, your applications, you keep improving it, right? And at a point it becomes an institutional knowledge for everyone within the team to be able to use. Everybody becomes better, everybody knows what to do. If it's not around, oh, I know what to do, they're able to fix issues, right? All right. So we've talked about certain, mistakes coming from the infrastructure to the security, to CI/CD pipelines, monitoring, a lot of those things. But if you notice the whole journey right now on to this point, you would see that many of these things, right, are caused by like little things that were ignored, that were seen, that seems like it's not really an issue, and all of those things, right? And this can be traced to actually like how you actually think as an engineer, right? How do you think? How do you deliver? How do you how do you build systems? How do you build your infrastructure? How do you build your CI/CD pipeline? How do you think when you build it? And that brings me to saying that because I see this with not just beginners but even early engineers, right, in the field still make these mistakes, right? And I think that's one of the things that actually cause people to run eta scatter when there's a new trend, everybody's just running, and it shouldn't be. Obviously, you should seek to improve yourself, but you should be well grounded enough to know that even if a new trend comes up, I still have my fundamentals perfect. Any new thing is just for me to learn and incorporate into what already exists. There's nothing different that is new again. No, right? So it means that you have to change that your thinking mindset now from tools, right? And think of what you do as a system. And I think one of the ways I usually explain this is just think from, let's say, how a user accesses your how a user comes and puts your try to access the application through a domain name and see the journey of what happens behind the scene, right? Let's say from the browser, right? It goes to, let's say, the browser, the cache in the browser. From there, it moves to the cloud. You see the CDN, the RAS-3, it resolves the domain name, goes to the ALB, and all that journey till it gets to the application and back. Having that broad mindset actually helps you to see that, oh, right now, okay, awesome, we have this all in place, good. So if this particular component fails, what is the blast radius? What is the issue that this application is going to? What is the effect, right? And you look at that because one of the things I do is that I just I obviously I have architectures, right, for any institution to be deployed, even project, personal project, I do architectures for them. So you just try to close out a particular service and ask yourselves, okay, if this service does not exist or something happens by any means, what is going to be the overall impact, the blast radius on the whole application, right? And that already signals to you, you know, how critical that service may be or how to actually build for resilience, right? Very important because while very early in my journey, it was more on tools because that was what we were actually introduced to learn Terraform, learn Docker, learn this, learn that, learn Kubernetes. There was a lot of noise. But if you look at it actually, every tool does not stand alone. They work together to actually obviously help the DevOps process of actually building software. So the goal is actually to be able to think in system, be able to see a broader picture of how you know traffic actually flows through the whole service and application, right? And that actually helps you to be able to think in a better way and build a more resilient systems. So very important, very important. And obviously that boils down to owning, like for instance, the pipeline, right? Not just the outcome as well is very important, which I've already talked about, right? Knowing owning your outcome, putting in things like rollbacks, strategies in place. If anything by any means happens, right, you have that in place, security in place, right? And yeah, talk about documentation as well. I think I'm reiterating at this point. Documentation is very important, very important. And the beautiful thing is now with AI, you can be able to document very faster with AI. Obviously, you can do a bunch of other things with AI, but uh, for documentation, instead of you writing, typing everything, you can use your AI to make a very detailed documentation on what has been done, go through it, edit it, make it fit and version it, and it becomes an institutional knowledge for anybody joining the team or even the organization itself. So that makes things very helpful, right? So if you look at these framework I have here, right? I have like a level 1 to 5, and if you look at each level, the first one is reactive, the second one is repeatable. If you look at the reactive, let's take one by one. The reactive is, you fix after things break, right? Right. You fix things after things break. And a lot of startups are actually at that level. When there's an issue, they quickly fix it. They taught the engineer, fix things. They are not really very keen on monitoring at that point. It's just to, let's say for pre-launch, just need to have like a server, database, load balancer, and also at least at that point. So I'm not really keen on that. And then you look at the second level, repeatable. At this point, you have a documented process. You have infrastructure as code tool, and your CI/CD is still fragile. So most startup actually they sit at those two levels, all right? But the idea actually is for them to come to the third level, right? Because the end of everything that we're discussing, right, is to be able to take up, be able to apply something, be able to make a change, improve eventually. And you don't need to make a drastic change. Like you can eventually use the same service the same way, not the same way you will plan for like 1,000 users, you plan for 1 million users. They are different. So, but the goal is actually to move a step ahead, right? To improve 1% and continually that way, right? So most startups sit as a level 1 and 2, but they are meant to be at the level 3, whereby you have standards in place, you have security gates, run books, and structured on call. So you have an engineer that obviously can be reached when there's an issue at all. And look at level 4, you see managed, measuring everything. These are measured, uh, data driven. You are basically making decisions now based on data. You can things are tagged in your Terraform configurations. You have the resources tagged, right? For cost also tagged, and you are able to track things right specifically. You are not guessing things. The data is actually decided. You can see it clearly, right? And for level 5, you see optimizing. That's actually a place where that's a position actually every organization actually ought to be, or actually should be, right? Where there is continuous improvement. You have a failure, but the impact of the failure is as limited as though it does not happen. And then you use that incident to build your knowledge base to become better and better and better and better. Because the best engineers are not the one that's probably do not face any issue whatsoever, right? Every engineer I know has probably broken production once or twice, or I've done something that have affected the users. But being able to learn from it, build on that knowledge, and make it such that it's impossible again to make that mistake is actually the goal. The goal. So I'm going to round up with this at this point. So what I have here is 5 questions that you should ask yourself as an engineer, right, before any decision. Which is very important. And these 5 questions are very simple. They are simple, but this can actually take you. This ones can take you one step from being a junior to actually a mid level, and a mid level to a senior, because the senior engineers I see, they don't do it. Yes, they do. They can do a lot of implementation, but many of them do a lot of reading, thinking, seeing how that they can prevent it from happening, thinking long term, right? So, what are the questions? What breaks when this skill? I've talked about this, right? When you have like an architecture and you just try to, let's say, cancel out a particular service and ask yourself, okay, what would break when these skills, let's say you have at 1,000 users now, when you have a 500K users, oh, what will happen? Can my service be able to hold it? Can my uh just my virtual matching with database and artificial load balancer be able to handle this? What do I need to do? Do I need to oh add an auto scaling group? Or when do I need to move to, let's say, containers? When do I need to use ECS? You think and you plan ahead. These are questions that help you to think like an engineer, help you to think like a senior engineer. So the second one here is, what is the blast radius if this goes wrong, right? What happens? What happens? Because you have to think of the worst case scenario, so that you you basically are you have to think of all the worst scenarios possible and think of how to remediate anyone that happens by any means. Because the goal is not to prevent failure or prevent any incident, because there's no platform that is 100%. No, 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 there's nothing. But the goal is actually to be able to recover from anything that happens as fast as possible, and be able to actually build system that can withstand changes, right? So talking about the blast radius, so if my server goes down, for instance, oh, will users be able to access my application? As simple as that sounds, you can start with something like an auto scaling group, such that if the server goes down, you already have a minimum and a maximum amount of server that should be up and running. So if one goes down, another one is being created immediately. And in no time, the application is up back, right? Third question, can we automate this so it never requires manual intervention? That's another important question, right? Because you want to be able to automate the manual toil of typing the same command. And the goal is not just to make things more easier, but the goal is to prevent errors, because manual intervention actually has a lot of errors in it, right? You have a lot of errors trying to run the same command. Just imagine trying to administer a kubedm, kubedm on a server. That long process of doing all of that, you can make a mistake on, let's say, typing a command and doing one of two things, because it takes a bit to do all of those things, right? To put everything in place, right? So if it can be automated, having a script that does it, check the script properly with different edge cases that it works, right? And then execute your script, and then take a cup of coffee and see things work exactly the way they would work every single time. All right. So the first question is, what is the simplest architecture that solves this today? Okay. I should be wrapping up in 2 3 minutes. So this is something that I've seen also, right? Because I work with startups, and the startup, obviously, they cannot be building infrastructure like how Google, Amazon are building them. You have to start from where you are, because they started from the same place. So I would usually say that the best solution for any problem is actually the simplest that solves that problem, right? There's no need for having fancy. There's no need to be something complex. If something simple can solve it, the goal is to solve a problem, not to try to impress with what you can do. No, that's not the goal. If just having um, an ECS Elastic Container Service can manage our current load and make everything seamless, all the heavy lifting is managed by AWS. Just use the Fargate. Just focus on deploying. Why not do that? Why try to go for Kubernetes and try to feel like you know what you do? That's not the point. The point is to look for the simplest architecture that solves the problem. Yeah, that's the goal. The entire the goal at the end of the day is the problem solved. That's the question. Management does not need to really care about what you did, the whole thing that you did, the magic you did. Is the problem is the results? Do you have results? Can users access our application? Is it up and running? These are things that are more permanent, that are more important to the users, right? That's why I said that your engineering skills must be tailored in a way that whatever you do impacts the business value, right? And the fifth question here is what does a post-mortem look like with this field, right? There are more couple of questions, right? And I took a time to write an article, but that was tailored to startups, right? But it's obviously the whole thing I talked about still applies to any organization, for any DevOps engineer. So, but what does the postmortem look like for these films, right? You're already thinking ahead of if there's going to be a failure. You have to actually be very proactive because uh, even the system that you're operating actually gives signs and symptoms of something. They give certain symptoms of, let's say, when an issue is trying to occur, right? You could see that, oh, there's an issue. It's telling you um what's this error message that you get. I don't know, I just forgot that. But it's giving you an error message of, let's say, take an action, a vulnerability. You have to, it's not very serious, but you have to like upgrade it and just like it's not important. It's I'll do it later. I'll do it later. Then a month later, it's compromised, right? So, like I wrote here right now, I said that engineers will become excellent and not the ones who make fewer mistakes. They're the ones who extract the maximum learning from each one and they build processes that make that mistake structurally impossible for the next person. And I believe that is how organizations should be. You should not be blaming a junior engineer for making some mistakes. It's because the system was not built to handle that mistakes, right? All right. Okay. I think I've gone through everything. I've exhausted it. So at this point, I would appreciate questions. I hope I'm still in. Okay, can everybody still hear me? All right. Okay, I think seeing a few questions. Can you see me, Olamide? I can see some questions. Okay, there's a question here that is okay. I can see a question here. It says,
Yeah.
ca- all right. I can see a
Okay.
question here. It says, can you
Let
please
me.
cite an example of things to automate? Okay, you said what? I can't hear you, Olayinka, if you're speaking. All right, I'll just go on with this
Go
question I
ahead
have.
with the question.
So, your line is breaking. Just permit me to go ahead, right? So, the question is from Ayodele Daniel. It says that, can you please cite an example of things to automate? Okay, I'll cite some examples, but the idea is to automate anything that obviously takes time. I mean, manual toil. You have to do everything every single time. So, there are a lot of things you can think of. Let's say You can start with, like for instance, now as simple as even automating. Let's say for me, when I want to do some practice or some project, I want to do a few things. I have to install Docker, and all of these things. So I know I have to do that every single time. So I just write a script to do it. It's simple, it's basic, but it saves me time of going to, let's say, the documentation to retrieve and write them and all of those things. So many things you can automate. You can automate um, the let's say your pipeline. The pipeline is a good way, is a good start of automation. So the build and push stage of your images of your application can be automated. That's the purpose of the CI/CD pipeline, to automate, integrate, continuous integration and continuous deployment. So from the start to finish, so nothing is manually done except when it comes to the case of continuous delivery, whereby an individual, a senior engineer or the management has to approve that this change goes live, right? In that case, obviously, you need to wait for the approval. For every single thing else can be automated, from testing the application, everything I've said. Just check the whole SDLC cycle, right? All those things can be automated, right? You can automate things like your creation of your database, because creating a database takes time, right? Um, Virtually anything that takes time to do, right? You just automate it, right? So I hope that answers the question. Uh, Olamide, are you there now?
Yes. Can you hear me?
Perfectly.
All right. Yeah. Thank you so much, Tolani. It's been a very insightful session. But before I let you go, my question would be: you made mention of having different environments for on your cloud platform, having a dev, a test, and a production environment. Now, for a startup, how significant or how achievable, I mean, and how cost effective do you think it would be to have three different environment for a startup? Now, I'm not talking about an enterprise. A
Hmm.
level platform for a startup. Do you think it will be cost effective? Startup who has probably just one cloud engineer. Do you think it is applicable to them also to um, have such different environments?
All right, thank you for that question. So it depends on the stage the startup is. So, the startup could be at a pre-launch stage whereby they did not launch their, let's say the product. They could have launched and they are getting traction. So it depends on where the stage they are. So let's say you are at pre-launch now. You've not even, let's say, you've not launched your products to the real users to use them and all of that. Definitely, at that case, you might not even have to use AW like cloud providers. You can just have a VPS from all of these what do you call it, providers. I'm not okay. I think Render. There are a few of them like that. Just have a small VPS that you can use to just test out things on that basic level. And I think those, they give free tier. AWS also have free tier, but I would say that you should create an AWS organization if you are in AWS ecosystem, right? Because it doesn't cost you anything, right? So you are basically preparing for the time whereby things begin to grow, right? So you like you asked me now, the dev the stage account, right? It may not be so necessary if you are in the stage of pre-launch. But let's say you've launched and are getting traction, right? You can have a dev environment. But you also have to actually put in place that, obviously, if you have any infrastructure, any services that were probably launched in the dev environment, when they are being used for their purposes, you delete them immediately, because that's another mistake that startup actually make. They leave it running 24/7 when you just need it for less a few hours. So uh, that's what I was going to say. I hope that answers the question.
Yeah, it does. Thank you, thank you, thank you, thank you so much, Talani. It's been a pleasure speaking to you, and I hope we'll have to do this again. It looks like there's a
Yeah,
lot you have to share. You have to do, we have
yeah.
to do episode two of this. We'll talk
Hmm.
about that, but thank you so much. Do you have anything to say before we call it a
Yes, I have something to say. So I think a lot what I'm saying obviously applies to everyone, but I'm going to be speaking more specifically to people that are just coming into the cloud and DevOps space because I think a lot of my focus is more on just people, like to bring them into the field and help them avoid a lot of mistakes. So what I'm going to say is that the first thing is in coming into the cloud space and learning a lot of bunch of things can seem very clumsy, very tiring, exhausting. But it's important to take it a step at a time, learn the fundamentals, Linux, networking, all of these things. Start gradually. Don't chase the trend, right? Use AI where needed, but don't outsource your thinking, all right? And also be able to also bet on yourself. Like take project that seems like impossible, do something, try it out. You know, the experience is something that remains with you, even if the project was not successful completely at the end. So I would just say keep learning and keep building. Thank you.
Hmm. All right. Thank you so much, Tolani. Thank you. And thank you also, Fermi, for assisting. Once again, this is Tech Talk, brought to you by Tech Tribe. This is where we bring on IT professionals, cloud professionals, people who are doing well in the industry to share their insight and experience to help others grow. Till we see you again, have a good evening, everyone. Bye.
Bye.